Flip a coin. Go ahead and call it in the air. Heads or tails. You think that's chance? You think it's random? It is not. If I know the exact force of my thumb, the exact mass of the quarter, the barometric pressure of the room, the local gravity where I'm currently standing, you don't need luck. I can calculate how it will land every single time. To a physicist, which I'm not, I'm an ex-PharmD candidate, a coin toss isn't random. It's just an equation with missing variables. We live in a macroscopic world, a world of cause and effect. If you knock a glass off the table, it falls, it shatters. Everything has a precursor, something that starts it. Everything's a domino, knocked over by a domino right behind it. The universe is clockwork, predictable, unyielding. But what happens when you need something that has no cause? What happens when your entire civilization depends on it? That's the topic of today's conversation, which is exactly what I do every day. Right now, there's an invisible war happening in the digital ether. Every time you send a private message, every time you buy a coffee with your phone, every time a hospital secures a medical record or a nation secures its power grid, you are relying on a lock. And the key to that lock is a random number. A number so unpredictable, no computer on earth could ever guess it. If you're new here, my name's Ryan, and all I do is talk about the latest advancements in tech. The irony is that the computers are strictly logical machines. They follow rules. They follow instructions. Ask a computer to be random, and it panics. It has to use an algorithm to fake it. It causes pseudo-randomness. It looks chaotic to you and to me, but given enough time, the pattern repeats itself. The mask slips. Think back to the Enigma machine of World War II. It has a mechanical marvel of encryption, but it was back then. It was cracked. Why? Because the machine had rules. It had patterns. The weather reports always started with the exact same words. In the world of cryptography, a pattern is a death sentence. A supercomputer can crack pseudo-randomness, and when quantum computers arrive, they will slice through it like a hot knife through a butter. So human beings got really clever. We look to the physical world. We try to harvest chaos. And how do you do that? We built machines that watch the atmospheric noise or measure the exact microsecond you tap your keyboard. We even use the radioactive decay of isotopes. We take these chaotic physical events and we feed them into the computer to make our digital keys. But the universe is incredibly stubborn. Even our best random number generators are flawed. They have bias. Roll the dice enough times, and the 6 comes up a fraction of a percent more often than 1. The coin is always slightly weighted. No matter how perfectly you mill the edge of a die, no matter how precisely you split a photon beam with a mirror, small systematic error creeps in. The dice are loaded. The universe refuses to give us a clean state, until now. Deep in Swiss Alps, the laboratories of ETH Zurich, a team of physicists just did the impossible. They didn't just find a perfect randomness. They engineered it. They certified it for all of eternity. They built the perfect coin. To understand, we have to leave the world of cause and effect. We have to dive down past the cells, past the molecules, down into the basement of our reality, the quantum realm. Down here, the rules of the universe are really bleak. They break. Things don't exist in one definitive state or another. They exist as a smear of possibilities. A superposition, they call it. The researchers at the ETH took 2 chips, superconducting qubits, and they cooled them down, close to absolute zero, a fraction of a degree above the ultimate freezing point of matter. Collider then, the empty void of deep space, they took these 2 chips and they separated them by 30 meters, connected only by a long freezing tube. Then they fired microwave photons between these two. And the magic happened. Entanglement. You've probably heard about this before. Two particles linked across space. You measure one, it becomes a 0 or a 1 instantly. The other particle knows, it reacts. Faster than the speed of light, faster than time. Einstein actually hated this. He called it spooky action at a distance. He couldn't stand the idea that the universe was playing dice or that particles could communicate faster than a cosmic physical limit. In 1964, a physicist named John Bell came up with a mathematical test to prove who was right. A way to show if the universe was secretly deterministic or if it was truly deeply super weird. We call it the Bell test. It's basically a line in a sand. If you pass it with high enough quality, it means there are no hidden variables, no secret gears turning behind the curtain. The randomness is real, but for decades scientists ran Bell tests and there were always loopholes. You know, maybe the detectors were too slow, maybe the particles were too close, maybe they were whispering to each other before the measurement was finished somehow. The ETH team closed the doors. They locked the universe in a room with absolutely no windows, so we can see if they're whispering to each other. Remember that 30-meter separation? Nothing travels faster than light in vacuum, not even information. Light takes exactly 100 nanoseconds to travel 30 meters. The researchers have measured the entangled qubits in less time than that. There's no time. There's no time for signal to cross the tube. There's no time for qubits to talk. There's no time for the universe to cheat. They use a slightly imperfect random number generator to choose how they measure the qubits. And then through a jaw-dropping algorithm, which I would never be able to understand because they're geniuses, the quantum entanglement strips away the bias. It takes the imperfect chaos, forces it through laws of quantum mechanics, and purifies it. They call it randomness amplification. So what comes out the other end? A sequence of zeros and ones. Perfectly, mathematically, unassailably random. Certified by the fundamental laws of physics. Well, this is the atomic clock of probability. We have started with a coin toss, a simple illusion of chance in a clockwork of the world. Grains of sand falling through the hourglass we thought we understood, which I have one behind me, and we ended up rewriting the foundation of digital security. We've come a really long way. This technology, this certified quantum randomness, it will become the bedrock of the future, the ultimate shield for global communications, for digital identities, for quantum secure internet. But step back from the cryptography for just 1 second. Let the technology fade away. Think about this and think about what this means about the universe we actually inhabit. We are surrounded by structure, the predictable orbits of the planets, the majestic sweeping spiral arms of galaxies, the ticking machinery of the cosmos. But down at the very bottom, in the cold, dark silence of the 30-meter tube, we forced the universe in a corner. We gave it no time to prepare, no hidden information to rely on, no precursor, no cause. We have actually forced reality to make a truly spontaneous choice. Next time you look at your smartphone or at your computer or when you're banking, next time you send a secure message into the world, remember what is protecting it. Not just math, not just clever code, but a bottled fragment of pure, unfiltered quantum chaos. We have basically reached into the deepest mysteries of space-time. If you have watched this video until now, say something nice or not so nice in the comments so I know you exist. Like this video if you want to continue seeing my videos in the future. And if this was interesting, share it with friends, and you better be sure that I'll be seeing you tomorrow.